Okay, so what we're actually talking about today is we're going to do a little bit on odor control, but what we're primarily going to be working on is trying to be able to troubleshoot where we have an air leak, where we end up with an error message on our reclaim system, which will usually come up and say no pressure at O2 or low pressure at O2, or we're getting possible ozone leaks, and we're trying to figure out where those leaks are coming from. So today, that's our purpose, is to go through this troubleshooting on the ozone system. So on the reclaim systems, we have a couple of different methods of odor control. And one of those, they're either using an air sparger, where we're introducing just regular air into the water stream by aerating it. And the other is through using a ozone system to inject oxygenated water into the water stream. As I said before, to inject ambient air into the recirculation water through an air sparger. This is a device that the recirculation water is injected into. As it passes down and through, it'll actually pick up the oxygen from the air and blast it down on top of the water, sort of like what happens with your aerator on your kitchen sink, where you get water that is not just a stream of water, but actually there's air bubbles introduced. And this would be the air sparger assembly. As you can see, we have where the recirculation line comes into the side. On top is an ambient air port. And from there, as the water passes into the mixing chamber and the water is then blasted down, it creates a vacuum, and it will pull the regular ambient air into that water stream and aerate it. As Paul described last week, if you walk in or you walk around the tank that has the air sparger in it, you should hear a sucking noise. And that would be where the water's passing through and pulling the air in. And that's one of the things we want to make sure that if you have an air sparger, you do hear that. And if you lift the lid or look inside the tank where it's at, you should see the water passing through that air sparger and blasting down on top of the water. We don't want it to be putting this in where it's inside the water. We want it above the water so that it actually is aerating that water. Drawing here, you can see where the air sparger is above the water line. And usually we want it to be in the, if you have 3,000 gallons of water, if each one of these tanks is 2,000 gallons or 1,500 gallons, each one of these tanks is 1,500 gallons, and each section in each tank is 750. So we're aerating at the beginning of the second tank, so that it is aerating and sparging that water to try to inject as much oxygen into that water to fight against the anaerobic bacteria.
One thing you want to make sure is when you do put a sparger in a tank, you want to make sure you don't put it in a tank like in the middle of the bay, the interceptor in the middle of the bay, having the sparger in there. Because when that sparger does fire down into that water, you do get a lot of foam and a lot of suds. So if you're going to put it in there, you see how it's in the tank, tank 2, chamber 1. That's where you want to see it. You don't want to put it actually where there's an open grate, because you will get a nice little snowman to come out of the ground, and it can cause some issues. I used to do that when I worked on some of the car wash equipment out there. You would lift up and it would block eyes and shut the car wash down because it's saying, hey, something's in the car wash. So just be aware that it does foam up when it sparges.
The second method for odor control is using introduction of a disinfectant chemical, chlorine, hydrogen peroxide, or ozone. Ozone is a contact killing agent similar to chlorine and used in city water. Ozone, O3, is generated by concentrating the oxygen, O2, in ambient air and taking the ambient air and passing it through an oxygen concentrator through a high voltage current to produce ozone. The ozone-laden gas is then injected into the recirculation water and returned to the reclaimed tanks. So To make this really simple is we take air from the outside, we pull it into an oxygen concentrator. The oxygen concentrator removes nitrogen and any other hydrogen molecules, and what we're left with is pretty much pure O2. Then we take that O2, it gets put into a high voltage chamber, and through electrical discharge, it then creates the O3. There is still some O2 in there as well as the O3. What happens is it separates the O2 molecules, and they will try it as a single oxygen molecule wants to adhere to something. So the first thing it tries to adhere to would be another set of O2 molecules. So then we end up with O3, which is our ozone. So we have in our systems, we have 12-gram ozone systems, 24-gram ozone systems, and these are producing 12 and 24 grams per hour of ozone. There are also 4-gram ozone systems and also 8-gram ozones. But for a lot of car washes, the 12 and 24 gram produce an ample amount of ozone to fight against the anaerobic bacteria to kill off the smell. In the ozone production, we have our oxygen concentrator. This treats the ambient air that is 21% oxygen and removes the nitrogen and moisture, resulting in a 90 to 95% discharge of O2. So the oxygen is, or the regular air, ambient air is pulled in, forced through the compressor, which is that device that's in the center at the bottom. From there, it forces the air through some solenoid valves and through the sieve beds. These are these two, they look like they're stainless, they're actually aluminum tubing on either side. And that removes the nitrogen and moisture, the chemicals that we don't want. And so what we're left with is our oxygen. And from there, it is then pushed out to the ozone system. In a standard ozone system, this picture you're looking at on the screen would be a 12-gram ozone. It has a single reaction chamber. On this particular ozone system, you have a single transformer and a drive board. There's a power supply inside it. And inside there's other components which we will cover in more detail. But on the front of this control box for the ozone cabinet, you can see an easy way to tell what size of system you have. If you have just a single temperature gauge, I'm trying to get my pointer up to it. On the front of it, this is a temperature gauge. If you have just a single temperature gauge, you have a 12-gram ozone system. You have a single cell. We have a red fault light. We have the blue ozone light, which looks white. And then below that is the green power light. Normally, if our ozone system is working, we have a pressure gauge, the cell pressure gauge, which is over here on the right-hand side. And then there's a cell pressure adjustment, an on-off switch, and ozone output.
We've got a machine running out here, and we want to take you through the actual ozone, the oxygen concentrator. So this is the machine running at this point. This is what you should be seeing when you're running the system. Pressure should be here. Good flow coming out of the oxygen concentrator itself. But say that you have a problem with the system where you can't build pressure in the ozone system. So we can go through and kind of figure out how to figure this out. So say that you have an oxygen leak coming out of this tubing and going up to the oxygen cabinet. I'm going to try to move slowly with this so I don't make anyone vomit. If you take this line off, we always start here. It's the first place we start when we've got an oxygen leak or a problem with the system. We're going to pull this line off, and what we should see is that ball should be at 6. That's a little high, but nothing substantial. Adjusting it up and down here. So with this full discharge coming out of here, we should be at 6. Now, if we want to check this oxygen concentrator, see if we have a leak inside of it, take your finger, plug it. See how that flow meter goes all the way to 0? Goes back up, plug it again. That verifies there's no air leaks inside the ozone, the oxygen concentrator. We can do the same thing. We plug this back in and we move to the next fitting. See how that actually drops down? That's where we want to see it. You can do this because I need 2 hands to get up here. Up in the cabinet, you got an air line coming into this ozone cabinet here. So we're going to pop that out. We're going to do the same thing. We're going to check this, plug it. Does it go to 0? If it goes to 0, that means this air line coming up is perfectly fine, no issues. So then we will reattach. Here, when you push it up in there, you're going to feel it pop through the O-ring. And then give it a little tug, make sure it's in there right, and you'll see. Then we'll move on to the next fitting. Trying to get up here is kind of an adventure, so let's move over to our lower unit. So what you're going to do after you go through the bottom fitting, you're going to go to this fitting next. So we're going to pop that line off. Inside the cabinet, we're going to do the same thing. We're going to put our finger on top of it and then look at the oxygen concentrator, see if that flow meter drops to 0. If the flow meter drops to 0, okay, our air is fine here, no leak. So we move on to the next fitting. Reapply that one and move on to the next fitting through the line, which would be this one. Go to here, plug both of these, and then you watch that oxygen concentrator again. Does it drop to 0? If it drops to 0, okay, all of these fittings from here all the way through here are all sealed up, no issues. Next one I'll do is I'll plug this back in here and let the machine roll away from me. And then I'll plug this one. So it's now checking this pressure switch. You plug that, look at the oxygen concentrator. Does it go to 0 again? If it does go to 0, okay, this pressure switch is fine. We're moving on to the next fitting. So we'll plug this back in here, and then we'll move on to this fitting right here.
That's the pressure gauge. That's the connection that's on the back of the pressure gauge.
That's the cell pressure gauge here.
So if there is definitely a leak of some sort, normally that cell pressure gauge will show where it is right now at 0 in the black, right in the center. So
then you get the same thing. Actually, we need to go plug this side too.
right, and usually what I would do, if it's easy to get to, is to remove it at the cells.
Mm-hmm.
When I talk about at the cells, this is a 24-gram system. It has 2 ozone cells. There's a T in between the 2 of them, and there's a small hose going to each one of the cells. What works best is to disconnect. Okay, so this hose has been disconnected between the 2 ozone cells. By plugging this hose, which is the last point coming through all of the plumbing that's in the ozone cabinet before the ozone cells. By plugging that hose and making sure everything else is in place, we got, I'm not seeing anything on that cell pressure.
You want to connect it?
Huh, that might help.
Here, this is going to help.
Okay. So now, plugging it, our cell pressure gauge should show what is on, it should be equal to what's on the oxygen concentrator. Right now, we're at about 11 PSI.
Exactly where we should be.
Which tells me then we do not have an air leak inside the system.
And we see this here, and then if you go down to the oxygen concentrator, see how it's at 0? full pressure, push it again, seal it up, and it will drop down like so.
If you had a leak, one of the things that happens at times is the pressure switch can get damaged. Either too much pressure or the diaphragm on the pressure switch. That's this little black piece right here inside the ozone cabinet. This is your pressure switch. If the diaphragm inside of it gets damaged, you will have it'll give you a fake, or it'll give you an indication that there is low O2 pressure. That's similar to, let's see if I can simulate by taking a hose. Even though the hose is somewhat in, I put my finger on it, and I'm just, I'm just barely making it get contact, as if the pressure switch is damaged. So if you take this hose off the pressure switch, plug the one from the cells and the one from the pressure switch, you should see your cell pressure gauge equal to what's on the oxygen concentrator. So I'm plugging both lines.
Is that screen shown?
It should be. Okay. If you want, let me go check. So, trying to decide where the actual leak is at, going from step by step by step. Sometimes it turns out it could be one of the T's, that we don't have a good connection where our hoses are pushed into the T's. Or it could be that the hose is just barely pushed in, but not all the way. And then if we try to do the test by blocking off, in fact, here, let's change places. If you look at your cell pressure gauge, the hose is barely into the pressure switch. I'm plugging it, and yet we only see it climbing a little bit into the yellow. That's an indication that, yes, we definitely have a leak there. And by giving it a little extra push,
There you go.
we don't have any leaks at this point. The cell pressure gauge, if there is a point in time where, let's say, you know you've got 11 PSI on it, but it's no longer down at sea level, or how we are, we're close to sea level, but you're up in the mountains. The pressure does change on it. On the top of the pressure gauge, kind of tough to see, but right here is a little rubber, there's a little rubber cap. By taking a finger, going in and just lifting that cap to break the air seal will equalize the pressure on that pressure gauge on the ambient outside to inside of it. And then when we test again, it should be reading normal.
Normally, you're going to find that when you do your first installation on the site, because when we test it here, we make sure this is at 0. And you may get there and you may see, with nothing running, you may see a positive 2-3 PSI. If you do see that, do that on the back of the gauge. Actually, any gauge that you have can do that. Your pressure gauges for city water pressure, anything like that, can show a positive if the pressure differential is there.
Okay. So let's say, so we've gone through the fact that we know from this point, we do not have any leaks from our oxygen concentrator to the ozone cell. We can then reattach the hose to the ozone cell. Okay, so now our oxygen line is hooked back up to the ozone cells to the incoming T. You do have a line that runs from each side of the T up to the input of the ozone cell. So on either side. Now, if you do have this point and you still are not able to, if the system is still showing as if we have a leak, we could have a problem either in these points here at the ozone cells, or it could even be something after the ozone cell. The input side is always a nylon, Teflon input. The output will always have a stainless steel fittings.
I always call it oxygen side, ozone side. Because if you put ozone through these fittings, it will eat them from the inside out.
Okay. So at this point, if we know that everything is working properly, we can adjust our cell pressure. Because right now, we're showing that we've got a little bit of pressure against the line, which is absolutely normal. By turning it clockwise, the cell pressure adjustment, we should be able to start increasing our cell pressure up into the green. Once we're in the green, if you look at your ball on the side of your oxygen concentrator, that should be about 3.5 to 4. So the ball will change depending on what our cell pressure adjustment is set to. If you were to close this cell pressure down, right now it's all the way closed. So coming through the oxygen concentrator, through the ozone cells, and then coming up to our cell pressure adjustment, with it fully closed, it's showing our 11 psi. At that point, we can then determine that, at this point, we can determine that there are no leaks in our ozone cells also, because the whole cells are now pressurized, coming in through where oxygen is coming into the ozone cell, coming out through the output side on the ozone. The line passes all the way down through the back. It then comes around to the back of the cell pressure adjustment. That's where my finger is, where that line is coming in. So at this point, all the way up to here, we are fully closed. We do not have any leaks. So if we're at that point, we know that's the case, we can then open our cell pressure, bring her back into the green. The line then passes out of that cell pressure adjustment, comes along the front. The line then comes to our vacuum switch. This vacuum switch is in place so that if there's a problem with the MOSI is the ozone injection point on the reclaim system. If we don't have enough vacuum on that MOSI, it will not hold this vacuum switch in an open state. And if that's the case, then it'll throw up on the screen an error saying no vac at MOSI or low vacuum at MOSI. Passes through the pressure or through the vacuum switch. There's a stainless steel check valve. This check valve is in place to keep any water from getting up into the ozone system. Because if we do get a problem with the MOSI, that we start getting low suction, the pressure from the reclaim system can force water through the MOSI back up the line to the ozone system, which we don't want to see. From there, it passes through a bulkhead, which is in the back right corner. And then from there, it's Teflon hose. We don't use poly hose, we don't use nylon. We definitely want to use Teflon hose. So from there, the back corner, I've got my finger on it, kind of. The hose then comes down. It's set so that it passes down from there. Comes down to the back here, down. The hose comes around, and it then goes to the ozone injection point, which is the MOSI. This whole piece, from this union to this union, this is the MOSI, this black piece in between. There's a big stainless steel fitting on it. And if you do get a problem where it says no vacuum at MOSI, what you want to do is remove this hose. Somebody cranked it on. With the reclaim running, you want to put your finger right here on this nice big stainless steel fitting. You should feel a suction. Now, I usually describe it as getting a suction that it draws a nipple on your finger. Now, I'm pushing really hard to kind of simulate what the nipple would look like on your finger if you have a good suction. If it's kind of like that, that's not enough suction. So it's a pretty good pull on your finger. It should be, because we've got how many gallons a minute? That's 15, 18,
17 to 18.
17 to 18 gallons per minute passing down through the Mozzie. The Mozzie is a Venturi effect. So you've got the high pressure coming in at the top. It passes through this section and then expands and creates a vacuum. So high pressure coming in, low pressure coming out. And from here, it passes down, and this is our recirculation line that goes back to the storage tanks. If you want to take this apart, the stainless steel fitting can screw right on here. This black plastic cap, you can remove that. Inside, there's going to be a rubber seat, and behind that is going to be a hard plastic ball and a spring. So that rubber seat, that hard plastic ball, and the spring, it works as a check valve. I'm pushing in on it right now. So the vacuum pulls that ball in, but I'm going to use my hand to catch the ball, and the spring is inside.
And that spring likes to run and hide from you.
It will, if you drop the spring, 9 times out of 10, you will never see it again. And if you do, it'll be like 6 months later. But inside, kind of tough to see, but in the very back, this line goes all the way back into here, and then there's a slit, a horizontal slit in the very back. So as the water passes through, it goes past that slit, and it creates that vacuum. If this gets gummed up with reclaim, or it's clogged up and it's not working properly, this can be all taken apart and cleaned. Notice you want to make sure you put the spring, the ball, and the seat all together at the same time. And this is just a plastic cap that screws on to the big stainless steel fitting. If you do get a replacement Mozzie, they may come where the nipple is still in place. We cut the nipple off so that we can fit the big stainless steel fitting on. So if you do see that big nipple, don't panic. You just cut it off. This screws back on snug. It doesn't need to be super tight. All we're doing is creating a good seal. If you need to remove the Mozzie, union on the top, union on the bottom, and the Mozzie comes out as one assembly.
And we kind of try to make it idiot-proof because each one is a male-female, so you cannot put it in there backwards. But I have had it shipped out of here with it.
There are some people who have actually put them in upside down, and it doesn't quite work the same as it should.
If you look right here, it shows you the flow.
Flow doesn't, the arrow doesn't mean point it up. That's our flow that we want to go. This would be one of your normal maintenances that gets done on the system. And then our ozone line.
Oh, we connect that back in. Let's kick the oxygen concentrator back on.
Yep.
So I want to take you, the oxygen concentrator itself, what should the settings be on it from normal settings? When you first start it up, it's going to take a second. The pressure is going to build. What you should see right there is 11 psi. That's exactly where we want to see it. To adjust that, you actually use this knob here, pop it out, and by closing this, you can increase or decrease the flow coming out of it. But we want to see 11, just like that. The gauge on here is going to build about 30, drop down to roughly 15. It's going to come up and down, just like this. Now, you get to a site and you've got 11 on this, and you got good flow coming out, but this in here is all the way up and it's almost 60 or 80 or 90 PSI. What that means is the life expectancy of this unit is trying to push the air through these sieve beds here, and they're plugged up. And you're not going to get the airflow you're looking for coming out of the oxygen concentrator. So you should see this go up to 30, drop down to roughly 15, come up to, and just up and down.
Also, after you make an adjustment for your oxygen concentrator, when you pull the knob out, made the change, we want to make sure we lock that knob back in. So through vibration, it doesn't change and change our pressure. So we push this knob back in place, it should click and lock in.
On the oxygen concentrator, there's an hour meter. This one has 3.7 hours on it. To replace or rebuild this unit, it's going to be roughly 16,000 hours you're going to hit. So if you ever want to know how much time is on the concentrator, pull the front panel off and look at the hour meter.
If you do take the cover off to check things out, please be aware there are fans on either end of the compressor. They spin very fast, they are very sharp, and they can sever components off your body. I'm just manually pushing on it right now, it's hooked together on both sides, but you want to make sure that you don't get your fingers in when it's running in here on the fans. There's also a cooling fan, it's a cooling and evac fan, so that this spins pretty good as well. Because what happens in the system, when it does that, when it's going through the system, you hear it make this like Darth Vader breath type thing, the exhale. What happens is pushing all that excess nitrogen out of the sieve beds. It comes out this little filter muffler. And then the fan takes that and pushes it out of the system, so we're not drawing it back in. So just be aware that you have at least 3 blades spinning inside this thing, as it shows right here.
Let's kick it back on.
Okay.
So if I have a problem with the system and I got the air leak we're talking about, first thing I'm actually going to do is let the system build up to pressure. So see that pressure building up here? Once I see, okay, I've got good pressure, or I don't have good pressure, I'm going to look right here. I've taken this off, the Mozzie off here. I can plug this right here and then look at the oxygen concentrator. And you see that zero. You just test it all the way through the whole cabinet to see if you have an error.
Also, and that's him moving his finger on and off the hose. But by also doing so, you can also look at the ball and check your cell pressure gauge, because our cell pressure is adjusted all the way. If you pump the hose, we should climb up into the red to 11 PSI, which we do. So you've checked every component from the oxygen concentrator all the way to the Mozzie. So, I mean, if you have any problems, you come into working on a piece of equipment, or you get where it comes up with a low vacuum or a low pressure O2, the first steps we went through and being able to check, first, make sure that the oxygen concentrator is working. I've had a couple of times where people say, hey, it says that my O2 is not working. And what's happened is either somebody in cleaning had turned the power switch off, and didn't bother to turn the power back on to the oxygen concentrator, or the circuit breaker on the side, which is right next to the power switch, had gotten tripped and it was actually in an off state. So things to check just to make sure that the oxygen concentrator is running, that we do have pressure on that gauge on the right-hand side by the on-off switch, and also that we do have a flow coming through our flow meter. Without the hose coming off the output, that ball should be at 6. And then if you plug it, it should drop all the way down to 0, which means we don't have any internal leaks on the oxygen concentrator. And with that being said, if there are no more questions, we'll call it a day. And next Thursday, we'll have another class.